Hello everyone, today we are going to discuss the fourth capstone topic, economics and the environment. It is also known as environmental economics. In previous units, we focus on the economy per se, but the economy takes place within the society and biosphere. Human activities are always constrained by and having effects on the social and natural environments. Today's lecture extends our scope from within the economy to the connection between the economy and the environment. In the big picture of the module, you can see that we are standing at one of the conditions facing the economy. It has wide impact on each component of the economy. In the big picture of the lecture, I summarize the relationship among the sections of Unit 20. We start with the key concept of environmental economics, externalities. Based on this concept, we discuss the environmental problems in economics. Then, we will talk about three important policies to deal with the environmental problems. The first is short-run abatement, which is further expanded in three directions. The second is long-run dynamics. The third is the main difficulties and challenges of implementing environmental policies. Please come back to this map while reading the textbook for navigation. Like always, we have two sets of questions to answer. The first two questions discuss the causes and effects of environmental problems. They are descriptive analysis trying to explain how things work. The other two questions discuss the policy implications to address environmental problems. They are prescriptive analysis trying to explain how things should work. First, why do environmental problems matter? In other words, what are the effects of environmental problems? The obvious answer is that the next generations will suffer from the consequences of actions taken by previous generations, and we do care about our kids. There are two types of environmental problems. The first is pollution, which will damage the living environment. The second is exhaustion of natural resources, both biotic and abiotic. There is a long list of environmental problems. To name a few, the loss of biodiversity through species extinctions. Every day, up to 150 species are lost. Pollution leads to lack of access to clean water and air. 790 million people do not have access to clean water around the world. The waste carrying capacity of the oceans is limited. Plastic wastes are found in everywhere, including Antarctica. Desertification and deforestation result in loss of natural assets and global warming. The slogan of many environmentalists is "Save the Earth." But they must be joking me. The Earth is there like 4.5 billion years, way before human beings. It is the human beings that need to be saved, not the Earth. Let me give you a math quiz to make the point. The Earth, as we know, is 4.5 billion years old. If 4.5 billion years is treated as 1 day, or 24 hours, how long is the human history of 200,000 years equivalent to? You can pause me now and calculate. Okay, the answer is 200,000 years divided by 4.5 billion years times 24 hours per day times 60 minutes per hour times 60 seconds per minute. That gives you an answer to 3.84 seconds. The entire human history is just 3.84 seconds if the Earth is 1 day old. And look at what we have done in those 3.84 seconds. The first row shows the pollution in the UK. The British couple in the black and white photo was taken after the Second World War. The second row shows the pollution in China, contrasting a polluted day and a good day of the Forbidden City. The Chinese couple in the photo tried to express their anger in an artistic way. The last row shows the pollution in other parts of the world, including Ganga River in India, Antarctica, poor penguins. And do you know where it is in the last graph? It is a typical Friday night on the St. Mary Street in Cardiff, where pubs and clubs are. Well, not anymore, because the pandemic makes the street quiet and clean for a while like never. So the pandemic is not all bad after all. Okay, let's look at the first environmental problem, global warming. Scientists use tree rings to estimate the historical temperature and compare with the current records. It is obvious that the temperature has an upward trend since the Industrial Revolution. One of the contributors is the carbon dioxide emission. It is hard to deny the connection between the climate change and human activities in the face of this evidence. However, the human race is good at accusing each other and bad at taking responsibilities. Carbon dioxide emissions are higher in richer countries in terms of per capita sense and in stock sense. But they use political powers to force poorer countries to give up the right of economic growth to take the same responsibility. As you all know, the US withdrew from the Paris Agreement even if it is the biggest contributor to emissions in history. Behind the emission lies the use of oil. The oil price was up and down due to various reasons. It can be due to the supply-side shocks, such as the oil crisis in 1970s and in 2020s. But it can also be due to the demand-side factors. An increase in demand makes the oil price trend up. As you can see from this figure, the sales of oil is ever increasing after the Second World War. But according to the estimate, we are going to run out of oil in 2030 if we keep using it at the current rate. Fortunately, electric cars are developing fast thanks to Tesla and its competitors, and the UK is going to stop producing petrol cars in 2040. Apart from the abiotic resources, biotic resources are also running out. This figure shows you how the Grand Bank fisheries in North Atlantic was destroyed by industrial fishing. The production was fairly stable up until 1950s. The fisheries could recover its number only if you do not kill them all. However, industrial fishing was introduced in the 1950s, and that was the real genocide. The number of fish can no longer recover if the number of fish cannot reach the threshold. Soon, the production dropped to zero in the 1990s. What a tragedy. The second question is to answer why these environmental problems arise. The key concept is external effects or externality. It is the case where someone takes the action, but consequences of that action are taken by others. In economic jargon, it means the private cost and benefit are different from the social cost and benefit. For example, a firm uses a pesticide that runs off into waterways. The consequence is, however, beyond the firm, because the pesticide can damage the downstream. This action benefits the firm but causes external costs to the downstream farmers. This is a typical case of negative externality. To solve this problem, the government can tax or penalize the firm to use pesticide so that the private cost is equal to the social cost. Another example of negative externality is when you take an international flight. You enjoy the international travel as your private benefit, but the flight also increases global carbon emissions, which are external costs beyond yourself. To mitigate this problem, taxes and quotas are introduced to avoid overuse of air travel. Then let's see an example of positive externality. If you pick up rubbish on the street, your action has some private cost because no one likes to pick up rubbish which does not belong to you. But your deed has a positive effect to the living environment for everyone. I used to ask my students how many of you ever picked up rubbish on the street? I'm pleased to see there are always one or two people said yes. This is very difficult. Many people talk about the rubbish on the street, but very few do anything about it. I don't want to ask you to pick up rubbish on the street, but at least may I ask you, do not throw them on streets. Because once there are some rubbish on the street tends to have more rubbish. This is the so-called broken window theory. Once a window of a building was broken, more windows tend to be broken because everyone thinks that this building was empty, so naughty kids tends to break the windows of that building. So if you can't be a saint, at least do not commit a sin. The third question is policy related. We acknowledge that pollution is inevitable, so we can't get rid of all pollutions at no cost, but to set an optimal pollution level. This is addressed by abatement policies. On the supply side, it includes discovering and adopting less polluting technologies. Tesla is one of such pioneers, and Wales is also a leading country in clean energy. On the demand side, it includes consuming fewer or less environmentally damaging goods, such as biking instead of driving. It also means banning or limiting the use of some environmentally harmful goods. The basic model for abatement policymaking is the cost-benefit analysis. In this analysis, we need to take into account of all the factors and all the stakeholders. To begin with, let's first assume all agents are identical, so everyone in this economy enjoys and suffers from the same environment, and there is no generational structure. So we have a homogeneous agent model. If the central variable of the analysis is environmental quality, then we can treat it as an economic good. Like any economic goods, there is a production function of environmental quality, and it is produced by input of abatement costs. The relationship between the input of abatement and quality of environment is concave. It means a higher input cost of abatement gives a higher environmental quality, but it becomes more and more difficult. Any area below this production function is technologically feasible, so the area is called feasible set. The feasible set indicates the relationship between the output of environmental quality and the input of abatement cost. A higher cost of abatement means a lower consumption of goods, so the feasible set can be equivalently expressed as the trade-off between environmental quality and consumption. If we combine the feasible set with the subjective indifference curve, we can easily work out the optimal choice, X. Point B is feasible because it lies on the feasible set, but the optimal choice, X, has a higher indifference curve. Any point on the highest indifference curve is preferred to point X, but they are not feasible, so choice X is the optimal point. At this optimum point X, the marginal rate of substitution, MRS, is equal to the marginal rate of transformation, MRT. This is the optimality condition of the best choice of abatement. The lower graph shows you the change of MRS and MRT along the horizontal axis. Only point X satisfies the optimality condition, that is, MRS equals to MRT. The previous model assumes everyone is identical or homogeneous agent. Now let's assume some heterogeneities. We assume the businesses receive profits from emissions, while citizens make their living in other ways like working. In other words, the benefits and costs of emissions are different to the two types of agents, the citizens and businesses. According to the principle of the polluter pays, marginal rate of substitution, or MRS, differs between businesses and citizens. As you know, citizens do not like polluted air, so they would like to have better environmental quality. But businesses care more about profits, so they would like to have less abatement or higher consumption. Point Z and point Y represent their optimal choices respectively. There is a conflict of interest between the citizens and businesses, so the outcome depends on the political bargaining between the two parties. In the US, for example, the Republicans tend to represent the interest of businesses, and Democrats tend to represent citizens. So the final reconciliation lies between Z and Y. Now we know the optimal level of abatement, but how to implement this abatement policy in practice? The textbook divides the policies in two dimensions. One dimension is to distinguish price-based policies, like taxes and subsidies, from quantity-based policies, like bans and quotas. The other dimension is to distinguish static from dynamic policies. Some policies focus on immediate effects, but others have a longer scope. This diagram illustrates the effects of different types of abatement policies. MPBA is the marginal private benefit of abatement, following a diminishing shape, like all marginal benefits. MPCA is the marginal private cost of abatement, following an increasing shape, like all marginal cost. If there is no policy intervention, then the optimal private choice is B, where MPCA equals to MPBA. That is, the marginal cost equals to the marginal benefit. However, from the social point of view, MSBA is the marginal social benefit of abatement, which is much higher than the MPBA, the private benefit. The gap between the MSBA and MPBA is the external effects, that is, the gap between the private and social benefit. So point Z is the social optimum, which results in the higher desired abatement level than the private optimum point B. To shift from the private optimum B to the social optimum Z, there are two approaches. The first one is solely relying on taxes and subsidies to push MPCA to the right until it crosses MPBA at point Y. It coincides with the social optimum abatement level. Alternatively, policymakers can promote MPBA, the marginal private benefit of abatement, by education and persuasion, so that less taxes and subsidies are used. It results in point W, which also have the same desired level of abatement. To summarize, today we have introduced environmental economics and attempt to answer 4 questions. The first 2 are the causes and effects of environmental problems, and the other 2 are about abatement policies. A small request after this lecture: please do not throw rubbish on the street. Thank you and have fun.